Okay, so can you please tell me about yourself?
Yeah, hi. I am from Maharashtra and I completed my graduation from Walchand College of Engineering, Sangli, with 72% of marks. And after graduation, I joined Netcracker Private Limited as a Java full stack developer. So there I worked on the technologies like Java, Spring Boot, Angular, and I also wrote various genuine test cases. And after that, I joined TCS and have continued working there. And over the span of 2 years, I have worked on various technologies like Java, Spring Boot, REST APIs, and Angular for front end. And so basically, our project allows customers to create and manage projects and associated tasks. So I worked on both front-end and UI design and back-end REST APIs. So along with writing many genuine test cases. So yeah,
Okay, so how much experience do you have?
yeah, I have 3 years, 1 month of experience.
Okay, okay. So you know JUnit and Mockito.
Yeah, I have used JUnit and Mockito in my applications.
So can you tell me about your understanding of JUnit and Mockito?
Yeah, so JUnit is a framework. I mean, basically testing framework that is used to write and run unit test cases for Java code. And Mockito is used to mock the dependencies. So suppose we have any class and there it is basically, let's say it is calling some third party services or databases, right? So we don't want actually to call them. Instead, we mock it and we just assume the whatever that service will be returning. So that like we can write the behavior like when and then that service and then return. So whatever it will return. So that way we can just pretend that okay it is returning and it is working correctly, and further we can proceed with our testing because we test everything even in the units, right? So we don't have to test integrated in the beginning itself. So that is why we use Mockito for that. So JUnit provides various annotations like test before each, after each, and then assert equals. So all these are from the JUnit, and then Mockito also we have add date of mock, or we can also use mockito.mock. So that way we can use, and then verify we can say, and when and then return. So all this we can use in the Mockito. So yeah, so these are the things mostly I have worked on with JUnit and Mockito.
Okay, okay. So what are the front-end technologies you have worked on?
Yeah, in front end I have worked on HTML, CSS, JavaScript, and then Angular JS. So yeah,
Okay. So what is the latest version of Java you have used?
latest version I have used Java 17. But the feature wise, mostly we are using Java 8 features only.
Hmm. Okay. Okay, so you have experience on Spring Boot microservices, right?
Yeah, yeah, I have.
Okay, so do you think that microservices is always better than the monolithic one?
No, microservices is not always better, because like whenever we are using microservices means, uh, like we have to manage many small services together, and again we have to make them interact with each other and all, right? So uh, microservice is good when the application is kind of complex, or it is large, or like we want to make it kind of a scalable and all. But monolithic is better whenever we have a like some small kind of project, or some POC kind of thing is there, or some startup is there and they want to just kick off in the very beginning stage they are. Okay, so product is in the very early stage. Okay, so in that case we don't have to make it very much complex. So first of all we should start with monolithic, and if the application is growing bigger, in that case we can move to microservices. There are the some scenarios like, um, let's say any company is using only for its internal use, and it's the number of users are very less, or the complexity is very less. So in that case there is no need to go to microservices. So yeah, so in short, like whenever the application very small and all, or very early stage product is there, in that case we should go for monolithic. And if the project is like kind of large, complex, or you want to scale it, in this kind of situation we should go for the microservices.
Okay, okay, nice. Okay, so how do microservices communicate with each other?
Yeah, they communicate. So we have a REST APIs. So basically, Microservice is nothing but REST APIs. So using those REST APIs, they communicate with each other, and they can communicate either through a synchronous way or asynchronous way. So in case of synchronous way, I mean REST API and all is used, and in case of asynchronous way, we also have the messaging queues like ActiveMQ, RabbitMQ. Yeah, so those can be used in case of asynchronous communication. So we also use a Fin client for it, and API gateway is like the one which is the front door, we can say, for the all the client calls which we make. And then the service registry is the place where all the services will be running. So like Eureka and all, so there the services will be running, and whenever through API gateway any API wants to communicate with other API, so in that case Eureka generates the dynamic IP address of that specific service, and it IP address can be, API gateway can hit that like that generated dynamic IP address. This is how the communication happens between the microservices.
Okay, okay. Okay, so how do you consume the external APIs?
Uh, to consume, like earlier we used to do REST template, but now we are doing a Fin client, or web client. So Fin client we are doing for whenever we want the declarative REST calls. So we have annotation at the rate of Fin client that we can give, and there we can mention the URL. Okay, and what kind of a request we want to do, like it is get request it is, so get mapping we can do, and we can mention under the interface that one. So that way we can call using Fin client. And then web client is also like whenever we are receiving, let's say, a monoflux and all, so in that case we can also use web client. So yeah, that is how we consume the external URLs.
Hmm. Okay, Okay, so how you create a Spring Boot application from scratch?
Yeah, so to create the Spring Boot application, we have Spring Initializer tools. So for this, we can refer spring.io website, and we can create the project, and we can add group ID, artifact ID, and whatever dependencies we want, like Spring Data JPA and all. So those things we can add, and then we can just say generate, so it will generate the template project for us, and that we further that we can import to our ID, and we can start development. And also there is another way is like we can for example we can directly generate to our ID directly, for example using STS Spring Tool Suite, or even in using IntelliJ, and um, there we can also directly create the uh, Spring Boot project, and we can add whatever we want the dependencies in that, and we can create there also directly. So yeah, so basically these are the two main ways we are using.
Okay, okay. Okay, so what is Spring Boot and why we use it?
Yeah, Spring Boot basically that is the framework. So it makes it easy to build a Spring application. So that is built on top of Spring only. So it removes lots of setup work, like XML configuration, dependency setup, or server deployment, right? So all so Spring Boot comes pre-configured with the servers, embedded servers, and like if you want, we can exclude also. We can add some other server also. So with Spring Boot, we just create the app and run it like a normal Java program. So it will have the embedded servers like Tomcat, and it will come like in default configurations. So it basically removes all the boilerplate codes, and it saves lots of time. So yeah, so that's what the Spring Boot is and its benefits.
Okay, okay. Okay, what is dependency injection? Spring Boot?
Yeah, it means Spring will automatically give us the object we need. Okay, so we don't have to create it manually with like new. So earlier we used to write new, and we used to create a new object, right? So for example, if a service needs a repository, Spring will give that repository to the service at runtime. So there are various way of injection we can do. So we can use at the rate of auto wired, or we can use constructor injection, and like Spring injects that dependency for us. So it basically makes the code loosely coupled, and it is easier to test and maintain. So it's one of the key features that makes Spring very much we can say powerful, we can say. Yeah.
So how exceptions are handled in Spring Boot?
Yeah, Spring in Spring Boot, we can use add the rate of controller advice, okay, and add the rate of exception handler. So to handle the exception in centralized place, so we can use these annotations. So instead of writing try catch block in like every controller method, we can catch and handle the common exceptions in one global class. So for example, if an entity is not found, and we can throw a custom exception and handle it at one place. So this basically returns the cleaner code, and we can share the response of this using the status code, messages, and whatever we want.
Okay, what is Spring Boot actuator?
Yeah, Spring Boot actuator that gives us built-in endpoints to monitor and manage the application. So for example, if we can hit the endpoint something like actuator health, okay, so that in that basically we can see if the app is running properly. And again we have matrix, so we can see the memory, CPU user and all. We also have logs, we can see logs. So similarly we have various endpoints which it provides. So yeah, so it is kind of very much helpful for like monitoring, and we can see the all these informations using this actuator.
Okay, what is the difference between REST controller and controller?
Yeah, REST controller is used for REST APIs. So whenever we use REST controller, so basically this is the composition of or combination of add controller and add response body. Okay, and add controller is used whenever we want to return like HTML pages. So MVC structure traditional way whenever we are using, so in which we return views. Okay, so in that case we can use only controller. Otherwise usually we use added REST controller for all the REST APIs.
Okay. And what is circuit breaker in microservices? Okay, first of all, tell me what is microservices?
Yeah, microservices is a way to break down the larger application into smaller and independent like services. Okay, so each microservices in this case does one job. Like it can be, let's say user is there. Okay, so it can be user service, then order service, payment service. So all these will be separately developed and it will be run separately. So we can also deploy them separately so to manage them. So whenever suppose any services goes down or any of the module goes down, so that will impact only that specific module, not the whole application. So basically whenever we want to manage a scale or uh, like whenever we have a complex application, so in that case we go for this. Yeah.
Okay. Okay, what is circuit breaker in microservices?
Yeah, circuit breaker we use for to prevent from the cascading failures. So let's say we have one of our service is down, and if another service keep calling it, so they will also slow down or they may crash. Okay, so circuit breaker basically stops the calls after a limit and gives the fallback response. So we can write the fallback method for that. So after some time it tries again to check if the service is back. And we have some tools like Hystrix and Resilience 4J to help, and we can implement all this. So it's like an we can say whenever we are not able to make the call to another microservices for some reason, in that case we have the backup plan. Like in the fallback method we can write like temporarily the service is down or whatever we want, and we can pass on that to the client whatever the client is calling.
Okay, okay. Okay, so what is caching and why we use it?
Caching is basically storing the results of something that takes time. So like let's say any database call is there or any API request is there which is returning and which is taking lots of time, so we can return it faster it next time. So instead of hitting database again and again, we just fetch it from the memory. So it improves the performance and reduces the load on our backend or DB. So usually we cache the things that don't change often, like whatever the data we wanted to get from the database or from the any other service. So if that is not frequently changing and data is huge, in that case we can use caching.
Okay. So What about with respect to Spring Boot? Do you know? Do you know the annotations you it?
Annotations yeah, so we have add rate of cacheable, so that caches the result the first time the user um, so the first time method run, and it reuses it next time. And then we have cache put at the rate of cache put, and we have cache evict. So cache put is like it always runs the method and updates the cache with the new result. So and when we have cache evict, so that is used to remove the data from the cache. So in that case we can use a cache evict. Yeah.
So which caching providers you have used?
Yeah, I have used Redis.
Okay, okay. Okay, do you know TTN in Radish?
TTL. Uh,
Time to live.
yeah, I know that. So TTL basically that means how long. So TTL basically means how long a cache entry should stay before it expires. So it helps like in keep the cache fresh. So after a certain period of time, the cache should be uh, uh, removed automatically, and next time it fetches fresh data again. So in Redis, we can configure TTL like 5 minutes or 1 hour. So yeah, so we can do that.
Okay, okay. Okay, do you think caching can cause any kind of problem?
Uh, Caching, yeah, I mean whenever we have a small data and if it is fetching faster, so we should not use caching.
No, that is fine. But suppose we have the use data only and we thought to use caching. So do you see any problem here?
Uh, yes, so it can cause sometimes issues. So I think one of the issue can be the memory issue. So if suppose too much data in the cache is there, so it can eat up the memory and it can ultimately crash the system. And second thing is that we need to check periodically that when we have to uh, update the caching. So basically, like our assumption should be correct, like after how much time that caching for a specific data should be updated. So yeah, so I think if uh, proper like time to live if we are giving, and we are setting the cache limit and all, then it is fine. Otherwise, it may cause a problem.
Okay. Okay, so what is the difference between array and array list?
Yeah, array in Java is we can say is fixed size, and whenever we define its size, we can change it, but it's also limit to holding only one type of data. So all elements must be the same type. So we can declare that like int array numbers equal to new int of we have to say the whatever the size of it. But in array list is that is the part of collection framework and that provides dynamic array. So it can grow like as per the need, and also with array list we get lot of built-in methods like add, remove, contain and all that. So initially the bucket of 16 will be generated, and as per it grows as per the number of items are filled, so it automatically based on the formula it I mean regrows the bucket of the whatever the collection in this case array list we are using. So yeah, so that's the major difference.
Okay, okay. Okay, what is the difference between comparable and comparative?
Yeah, both we use for the sorting of the objects, but comparable we use inside the class whenever we want to sort. So it allows the object to compare itself with another. So we have to implement compare to method for this, and comparator is used outside of the class, and we can define custom sorting logic without changing the class. So we can use compare method in this case. So yeah, so this is the difference between these two.
Okay, that's fine. But in which scenario we should go for comparable and which in which scenario they should go for the comparator?
Yeah, scenario like let's say we have an employee class and it has various properties like name, age, salary, and all. So suppose our requirement is to sort only based on the age or only based on the salary. Okay. So in that case, we can go for the comparable because we know there is only one property based on which we want the sorting. But suppose in this class, sometimes we have to sort based on the its name, and sometimes based on the salary, sometimes based on some different property. So in that case, we should use comparator. So yeah, so that's the scenario when we should use these.
Okay. Okay, so what is serialization and deserialization in Java?
Yeah, serialization is the process of converting a Java object into byte stream, and again converting back from the byte stream to back to object. It is called deserialization. Okay. So basically we can store it on disk or send it over network. So all this we can do. And so basically whenever let's say we have any bean class, so in that on the properties whatever it has, so on that we can use the serialization. So for that usually we let's say we have a student class, so that implement serializable we can do. So it will automatically serialize all the properties, and we can use transient if we don't want to serialize any one of the property.
Okay, okay. Okay, what is the parent class of all exception classes?
Yeah, the root class of all exceptions and errors is throwable. So like we have on the top throwable, then we have exception error, and then under exception we have runtime exception and compile time exception. So yeah, that's what the whole hierarchy is.
Okay, okay. Okay, what is the difference between a string buffer, and a string builder?
Yeah, string is immutable, and string buffer and builder both are mutable. So so string, so immutable basically means that once it is created it cannot be changed. Okay, so that is a string. And a string buffer is like it is mutable and it is thread safe. Okay, and a string builder is mutable but it is not thread safe. Okay, so yeah, so that's the difference between these. And since string buffer is like uh, it is thread safe, so it is slower, and a string builder is faster because it is not thread safe. So yeah, so that's the difference between these three.
Okay, okay, good. So, what is the difference between method overloading and method overriding?
Yeah, Method overloading basically is compile time polymorphism, and method overriding is runtime polymorphism. So overloading basically means that same method name is there and different parameters are there in the same class. So at that time we say it is method overloading. Okay. So for example, let's say we have a method name, let's say void show. Okay. And we have some implementation there, and again we have another method like void show, and that also accepts one string parameter. Okay. So this will be method overloading. Overriding means like it is runtime polymorphism. So we have a same method name and parameter in a parent and child class. So here we have the parent and child class concept will come. So in that case it will be method overriding. So child class provides its own implementation basically. So let's say we have a parent class and it has void show, and child class extend parent, suppose we are saying, and we are overriding show here. So in that case this is the method overriding. So yeah, so that's the difference between these two.
So what is the use of this and super keywords?
Yeah, this basically refers to the current class object. Okay, so it is used to like resolve various I mean variables and all. So we can apply this dot name and whatever. So it means the current class. I mean in current object, in current class the object is being used. And super, it refers to the parent class. So it uses to access parent method of the constructor. Okay, so that's the super.